Alright, section 8.3. We're going to continue with factoring. But let's do a little review of what we've done for factoring so far. We started by looking at trinomials, things with three pieces, where this first number, the leading coefficient was always 1. And we saw that when we had a trinomial with the leading coefficient 1, it was going to factor into two binomials. Since we have x squared here, this had to be x and x. And then we looked for two numbers that would multiply together to be 24, negative 24, and add together to be a negative 5. And pretty quickly we generally came up with 8 and 3. And we would determine that the 8 had to be negative and the 3 had to be positive. Negative 8 times negative 3 gives me the negative 24. Negative 8x plus 3x gives me the negative 5x. Then we looked into problems where sometimes the leading coefficient wasn't 1. For example, here we have a 2. But we did notice that everything was even, so we noticed we could factor out a greatest common factor. So we look for our greatest common factor and we take that out. We're left with x squared plus 7x plus 12. And then we recognize that we had a trinomial left. So we're going to have the 2. And generally a trinomial will factor into two binomials. Again, it has to be x and x to get that x squared up front. And I think on this one, how about a plus 4 and a plus 3? Oops, I said 3 and I wrote 4. 3. Because 4 times 3 is 12, 4 plus 3 is 7. Okay, and then the next thing we did is we learned how to factor when we had 4 pieces. And when we had 4 pieces, our technique was to group, and we grouped them in pairs. So we'd look at this pair, we look at that pair. We begin by taking out the greatest common factor. In the first pair, the greatest common factor is an a squared. And left over 5x plus 2y. Then we noticed we had a minus here in the middle. So we're going to have a minus here, and we're going to factor out a negative quantity. So we're going to take out a negative, and we notice that the common factor is a b. And that gives us left over a 5x. And then we remembered that if we factored a minus out here, this sign in the middle had to change. So that becomes a plus 2y. Because I need minus b times plus 2y to give the minus 2by there. Alright, if we were doing things correctly, those two parentheses things should match up perfectly, and they do. So we can go ahead and factor that out as our common factor, 5x plus 2y. And then left over is a squared minus b. Okay, so we're going to kind of combine all three of those thoughts into a new type of factoring that we're going to do today. So what's going to happen? We're going to have a trinomial, 6x squared minus 19x plus 8, where our leading coefficient is not the number 1, our leading coefficient is the number 6, but there is no greatest common factor. 6 and 8 have a 2 in common, but 19 doesn't have anything in common. Okay, now, there are two different ways to do this. What I would consider the good way and the bad way, and I'm going to do the bad way first. And you'll see why it's the bad way. The bad way is we simply guess. We know that a trinomial generally factors into two binomials. We look, we have a 6x squared in the front here. To get 6x squared, I could possibly use a 3x and a 2x, or I could use a 6x and a 1x. And the reality is there's no way to know which one is the right one. So I'm going to guess, and that's what we do. We take a guess. I'm going to guess it's the 6x and the 1x. 6x times 1x would give 6x squared. And then I look at the number at the other end. That's an 8. To get an 8, I could use 4 and 2, and I could use 2 and 4, and we're going to see it makes a difference which order you put them in. Or I could use 8 and 1, or I could use 1 and 8. And again, there's no way to know which one is the right one, so I'm going to guess. I'm going to guess a 4 and a 2. And then I just try to see if I can make it work out. So I kind of do a FOIL here. I notice when I do FOIL, I've got 6x squared And then on this one I would have a 12x. On this one I would have a 4x. And on this one I would have an 8. And then I try to see, is there any way I can make my signs work? And really what I'm looking at is the two middle ones. I have a 12x and a 4x. Can I get a negative 19x out of that? Well, I don't think so, because even if both of these were negative, so if I had two negatives here, that would give me a negative 12x minus 4x. That would only be negative 16x. That doesn't work. So what does that tell me? It tells me my guess is wrong. But I don't know what's wrong. I don't know if the 6x and the 1x are wrong. I don't know if the 4 and the 2 are wrong, or maybe they're in the wrong spot. Let me show you what I mean by in the wrong spot. We know that doesn't work. So let's stay with the 6x and the x. But maybe now we put the 2 here and the 4 there. And you're going to see we get different numbers. When I expand this, that would be a 6x squared. This would be a 24x. This would be a 2x, and that would be an 8. And again, I look at my numbers in the middle, and I'm trying to see, can I get a negative 19? And again, there's no way from a 24 and a 2 I can make those add up to be a negative 19. But do you see how changing the numbers made a difference? If I had a 4 and a 2, my middle numbers were 12 and 4. If I used a 2 and a 4, my middle numbers were 24 and 2. In the past, the order that we put them in didn't matter. Back up here, if I had written x plus 3 and x minus 8, it would still be okay. And that's because there's no numbers up here. We don't have to, when we expand, we don't have to multiply by any numbers. So back here, order didn't matter because these were both 1s. These are not 1s anymore, both of them. Okay, so again, this is the wrong answer. This combination isn't going to work. Again, I don't know what's wrong. I don't know if the 6 and the 1 is wrong. The 2 and the 4 with the 6 and the 1 doesn't work. I know that. But maybe it should be 8 and 1. Maybe it should be 1 and 8. Maybe it should be 3x and 2x. I don't know. So I guess my point is, this is the bad way, because you can be guessing for a long time before you get the right answer. I have seen people who are excellent with number skills and they can get the right answer the first time almost every time, but that's not most of us. Okay, so now I'm going to show you the good way. Here's what we do. First off, we notice we have a trinomial. 1, 2, 3 pieces. We notice there is no common factor, and we notice this is not the number 1. What we're going to do is we're going to multiply the numbers on the end. So I'm going to take 6 times 8. 6 times 8 is 48. Then what I need to do is I need to factor the number 48 so that my two terms add up to be negative 19. Little work here. I notice that 48 is negative 3 times negative 16. Okay, so you might be using your calculator there. You might take 48, divide by 2, see if those numbers will add up to 19. Take 48, divide by 3, hey, you find it. Negative 3 and negative 16 add up to negative 19. Negative 3 and negative 16 multiply together, I'm sorry, negative 3 and negative 16 multiply to be that 48. So here's what we're going to do. We're now going to use these two numbers. So I'm going to go back to my original polynomial, 6x squared minus 19x plus 8, and I'm going to rewrite it as 6x squared minus 3x minus 16x plus 8. Notice what I did. I used these two numbers to split the 19. I split it into two pieces. The advantage of this is now I have 1, 2, 3, 4 pieces. When we have 4 pieces, we know what to do. We group them in pairs. First group has a 3x in common. Left over is 2x minus 1. The second group, I notice I have a minus there, so I'm going to have a minus here. And they have an 8 in common. 2x, I once again remember that this sign in the middle changes when I bring the minus out front. And once again, I'm pretty sure I'm doing it correctly because these two things match. Final answer. 2x minus 1, 3x minus 8. So here's the deal. It's not easy. Don't get me wrong. Doing it the good way is not particularly easy. The advantage of it is you get the right answer the first time, every time. Where with the guessing method, I was off to a very bad start because it turns out that 6x and 1x weren't the right things. I should have been using 2x and 3x. But I had no way of knowing that when I started. I just had to try. Alright, so there's the same problem over again. We just did that one. Let's try number 3. Number 3, once again, the thoughts going through my mind are, I count, there are 1, 2, 3 terms. I notice this is not the number 1, but I also notice I have no common factor to all 3. So I begin by multiplying my ends. I take 8 times 4. 8 times 4 is 32. I need to factor the number 32 so that my factors multiply to be 32 and add to be the number in the middle, negative 33. Well, let's see. This time I think I can just use negative 1 and negative 32. Negative 1 minus 32 is negative 33, and if I multiply those together, I do get 32. So I come back here, and I go 8x squared. Instead of this minus 33 RW, I'm going to use a minus 1 RW and a minus 32 RW, and then I still have the plus 4W squared on the end. Once again, the whole advantage of doing it this way, we split into 4 pieces. Once we split into 4 pieces, we know what to do. Take out common factors. Ooh, I don't know where that X came from. That's an R, by the way, right there. In the habit of using X's. Alright, so I look. Common factor, well, the only thing common here is an R. So I'll take the R out. 8R minus W. I don't really need to write the 1, so I'm not going to. Once again, pulling a minus out here. I got a 4 common, and I also have a W. So I take out 4W. Left over is going to be 8R. And then again, I'm pulling a minus out on the front here, so this sign is going to change. That's a minus. I took away a 4W, so I guess the only thing left is a W. Built-in self-check. Those two things have to match. If they don't, you made a mistake. Go back and fix it. I take out my common term, 8R minus W, and I'm left with R minus 4W. Alright. I want you to try 4 and 5. Okay, number 6. Number 6, same thought process to start with. I look, 3 terms, no common factor everywhere, multiply my ends. 6 times 4 is 24. I need to find 2 numbers that will multiply to be 24 and add up to 7. Well, I start thinking, let's see, 24, I could do 1 and 24. I could do 2 and 12. I could do 3 and 8. I could do 4 and 6, and that's all of them. And I don't see any pair that I can use to get a 7. So you know what that tells me? It doesn't work. This is prime. So think about how wonderful that is compared to what you would have to do if you were going to guess. If you were going to guess, you'd have to build your 2 binomials, and then, okay, you might say it's 6y and 1y. And then you try 1 and 4, and you find out that doesn't work. So then you try 4 and 1 and find out that doesn't work. And then you try 2 and 2 and find out that. You'd have to go through and guess every single possibility, try them all, and show that it doesn't work. That would stink. That would take a long time. Doing it this way, if it's prime, you're going to know right here. You checked all your factors of 24. No way you could make one of them add up to a 7. So you're done. That one's prime. Okay, number 7. Good one for you to try. The last thing that shows up in this section. Sometimes we have trinomials where we do have a greatest common factor. For example, greatest common factor here is the number 3. So I pull out the 3. I'm left with 4x squared minus 9x plus 5. But I notice I still have a trinomial left, and I do not have the number 1 in this front position. Alright, so this tends to really bother students. They're generally not sure what to do with this 3. Here's my answer. When I get all done, I know my answer is going to look like this. It's going to have the 3, and then it's going to have those 2 binomials. So what I do is I forget about the 3 for a minute, and I like to come off to the side here and just deal with this trinomial. So I'm going to come off over here, forgetting about the 3 for just a minute. I'm going to factor this, and then when I get all done, I'll simply plug in the 2 answers that I got, and that'll be my final answer. Okay, well, trinomial, 1, 2, 3 pieces. Leading coefficient's not 1, no common term. I multiply my ends. 4 times 5 is 20. I need to factor 20 to make it add up to a -9. Well, I think the 4 and the 5 that I had were real nice, except I used negatives. -4 and -5 add to be -9. -4 times -5 is 20. So I'm going to come over here to my 4x squared. I'm going to split this into a -4x and a -5x. And then I still have the +5. And it's kind of the same deal over and over again. 4 terms, group them in pairs. First pair has a 4x in common. Left over is x minus 1. We have a minus here, so we're going to put a minus here. Common factor is a 5. X minus 1. Same deal over and over again. Remember when you put this minus out here that this sign changes. So we have x minus 1 and 4x minus 5. Okay, so my final answer to the problem that was asked. I have the 3 out front. I have an x minus 1. And I have a 4x minus 5. There's my final answer. Okay, I'm going to do one more. I'm going to do number 9. And then you'll have 2 more to do for homework. Once again, I count my pieces. I see 1, 2, 3 pieces. The next thing I notice is I have a common factor. My common factor this time is the numbers all have a 6 in common, and I have a common variable. I have x squared everywhere. So sometimes you can take out a number, sometimes you can take out a number in a variable. What do I have left over? Left over I have a 6x squared, I said, on the 5th, 6x squared, minus 5x plus 1. Okay, same deal. I notice that I have a trinomial. I notice my front thing is not 1, but what am I going to do with that? Well, I'm just going to write it down. And then when I get done, my answer is going to look like this. So I'm going to come off to the side and figure out what I need. 6x squared minus 5x plus 1. Alright, well, let's see. This is not the number 1. There are 3 pieces. I multiply the ends. 6 times 1 is 6. I need to split up the number 6 so that I get a -5 in the middle. How about -2 and -3? -2 times -3 is 6. -2 plus -3 is -5. 6x squared minus 2x minus 3x plus 1. 4 pieces. 2x is common in my first group. Looks like a 3x minus 1 left over. A minus, because that's a minus. And here I notice I don't have any common term. But that's okay, because I take out this minus. That means this becomes a 3x minus 1. Got to change that sign. And I know I'm okay again, because those match. So it's okay if you don't have a common term on one of these 2 pairs, as long as these match when you get done. That means my common factor is a 3x minus 1, and left over would be a 2x minus, if there's no number here, remember it's just a 1. Okay, so here's my final answer. My final answer is I got that 6x squared, Then I need a 3x minus 1 and a 2x minus 1. Alright, so you are going to do problems 10 and 11, and you're going to bring it to me, and I'll grade it. As always, please contact me through email or come to my office or call my office if you have any questions, and I'll be glad to help.